Well, good morning, everybody. It is an honor to be part of this series of webinars and a true pleasure to be able to share all this with you. Unfortunately, we cannot be there with you, which would have been an even bigger pleasure. So tonight, I'm coming to you from Halifax, which is the Indian unceded territory of Mi'kmaq, an Indigenous peoples on the east coast of Canada. So my goal today was to give you an overview, a very broad overview of marine spatial planning and conservation in relation to deep sea mining. So let's start with marine spatial planning. We all live, many of us live very close to the ocean. Most of you are your lives are very tied to the ocean. And what this picture here illustrates is the various uses that we have for the ocean. So we use the ocean to transport our goods. We use our ocean to extract various resources such as oil or wind. We use our oceans for aquaculture, to fish, but most importantly, we also use our oceans for recreation. So here, for example, is a scuba diver, or to just simply sit by the beach and enjoy a warm or a cold beverage on a nice sunny day. Now, marine spatial planning is a public process that looks at all these activities and analyzes and allocates the temporal and spatial distribution in the area that you're trying to manage or to plan for. And to do this, it does this to achieve ecological, economic, and social objectives that somehow have been specified through a political process. So it takes all those activities that I just showed you in a previous slide and tries to manage them, tries to organize them both in space and in time. Now, importantly, what the process of marine spatial planning does is it brings together multiple users. So for this example, industry, government, and conservation. And it's importantly also very tailored to each unique area. So we don't do marine spatial planning for the globe. We're just targeted to whatever the particular ecological, economic, and objectives are in a particular region. And because it looks at this big picture, it very much helps implement ecosystem-based management. And lastly, it allows informed and coordinated decisions for sustainable ocean use. And so this is a slide that is focused on the Atlantic, but it illustrates some of these multiple activities that take place that are connected somehow to the deep sea. Here's an example of a slide that shows the landing of tuna throughout the North Atlantic, and larger circles mean larger landings. So obviously fisheries are occurring in this region. Shipping occurs in this region. So this is a map that shows lines of transatlantic shipping lanes, and the warmer the colors, the more ships are crossing the ocean. This is a picture of mineral resources and how they are distributed in that same ocean basin. Picture of turtle tracks. These are endangered species that are migrating across the ocean. So you can see that there's a whole lot of stuff that is going on. And superimposed on that are areas of particular ecological and biological significance that are showing down on the bottom slide here, and even marine protected areas and vulnerable marine ecosystems. So a lot of stuff is going on, and all those activities somehow have to be coordinated if we want to produce a reasonable marine spatial plan. Now, the first thing that is needed to do an effective marine spatial planning is to do what is called a strategic environmental assessment. And so the SEA is really a decision-making process. So what it does is it will take a particular plan, a program, or a policy, and it identifies and evaluates what are the environmental implications of that plan, program, or policy. Let's say deep sea mining, let's say fisheries. Then, after identifying the implication, the process establishes long-term environmental objectives. So this is a process that applies broadly to a geographic region or a whole sector of activity. So it's not, a specific small area where it may address one particular location and one particular activity. And it looks at long-term environmental objectives. So based on those objectives, then, a plan of action will be developed that will allow whoever the group is, the regulator that is trying to is doing the ACA, to come up with ways to achieve those objectives. Each plan is then assessed against specific criteria. So for example, they might be decided that there's acceptable levels of environmental change that can be caused by a specific activity. So those criteria are set against those objectives, and then a plan of action is developed relative to those criteria. And then the most desirable plan of action is selected, and then it's implemented. Again, it's a broad process, but importantly, it looks at objectives and then assesses those objectives against specific criteria. So this sort of schematic here illustrates the steps that should be going from planning on developing a plan on how you're going to manage your activities and your resources, all the way to management applications. So the first, again, most important thing is that you need to define your goals and objectives. You need to know what you're planning. You need to know what it is that you're trying to manage and how. And if you have environmental objectives, what those are. And then the next steps are data evaluation. So you collect data that allows you to describe different aspects of your ecosystem. So you can do, in this case, oceanographic analysis, what the currents are, biological analysis, who lives there, habitat analysis, how are those habitats distributed in your area. And then on top of that, what you need is socioeconomic analysis that tells you something about the economics of the particular activities that are a particular region. So all that comes together then, and then the regulator decides on what the management, the appropriate management will be to achieve those goals and objectives that you set out in the planning. So you're always going back to your goals. And so you heard a little bit yesterday, a lot actually, about this section here of data evaluation, acquisition, data gap identifications, etc., with respect to deep sea mining, and I will return to this near the end of this talk. So this is one attempt to try to see how we go, how do we define what those goals and objectives are with specific application to deep sea mining. So the goal would be a broad statement. For example, we're trying to sustain marine ecosystem integrity, and this is something that the International Seabed Authority will have to set up as an overarching goal. Now, that goal, associated with that goal, are your more specific objectives. This is based on how you manage the region or your resource based on those objectives that you set up. So for example, an objective that will link to sustaining marine ecosystem integrity is maintaining the ability of population to replace themselves. That's what you're trying to do, right? So you have deep sea mining. This is what you want to make sure that happens regardless of what you're doing with deep sea mining. Ultimately, this is what you're trying to achieve. So then, in order to achieve that, you need to set a target that is measurable and achievable, right? It has to be specific, so you can actually then take measurements to see if you're actually meeting your target. So an example here would be, you want to make sure that in the areas that you protect or you close or whatever your management aspect is, populations can self-recruit. Okay, so that's an example, because if they can self-recruit, then that means they can maintain themselves. So then you set up specific thresholds of how big an area has to be, for example, how big a population needs to be spatially to have the ability to self-recruit. And then you set indicators that will allow you to see if you're meeting that target. And so in this case would be you're measuring the rate of recruitment, for example, and then we know that if your recruitment is equal to 1, then they're self-recruiting. The population is replacing itself. And in order to set those up, we're getting back to this baseline data that we were talking about yesterday and the day before. So unless you have baseline data, you cannot really set up your indicators, your thresholds, and then you can never really identify if you're meeting your target. And so this is important. We really need good baseline data that will allow us to set those targets. Now, one of the most commonly used tools in spatial planning and management and environmental management is, of course, marine protected areas. And I'm sure many of you are extremely familiar with marine protected areas. It is one of the tools in a wider ocean management system, and you can have a range of uses. And marine protected areas really limited use, and ideally, they're areas where there is no entry. There's nothing that happens. They're completely closed and protected from any human activity. So what exactly are marine protected areas? I like to use the definition that is developed by the International Union for the Conservation of Nature, which is a global organization that has members from 170 countries. And so according to IUCN, a marine protected area is a clearly defined geographical space, recognized, dedicated, and managed, importantly, managed through legal or other effective means. And the purpose of it is to achieve the long-term conservation of nature with associated ecosystem services and cultural values. All the stuff we have been hearing about from my colleagues in the previous 2 days. And so the Convention on Biological Diversity is an international agreement that treaty that many nations have signed on, and it has identified criteria for marine protected areas. So how do you pick them? What do you want? What would you close? So it could be a place that is really unique, right? Special character. It has special character. It's particularly important for the life history the species. If we think about coastal regions, it could be the place where fish go to spawn. It could be important because it provides a habitat to threatened species, or it could be particularly vulnerable. So these are criteria for individual marine protected areas. But of course, it is recognized that one single area is not going to afford protection at the level that is actually needed. And instead, what the CBD has proposed is to actually develop criteria for networks of marine protected areas. And so those networks are now collections of marine protected areas that have certain criteria themselves. And so the first one is that they have to be representative. So if you have different habitats, you need to be able to represent all those different habitats in your network. So for example, when we're talking about the nodule areas, you want to make sure you have areas with nodules, and you want to make sure areas where nodules are not as dense, etc. So represent your range of habitats. And you want to ideally be able to have more than one copies of those habitats, because if something happens to one, you want to make sure that you have another one. So you don't just have one area with nodules, you have more than one. And then the other characteristic that is very important, and everybody has been alluding to, is this issue of connectivity. And connectivity, the criterion is that we want to maximize and enhance connectivity between individual MPAs and between groups of MPAs within a network. And so this issue of connectivity is so important that the IUCN has actually now come up with conserving connectivity as an additional target or objective in our toolbox of marine protected areas. So we have individual marine protected areas, we have networks of marine protected areas, and now it's proposed that we have ecological networks and corridors that are actually conserving connectivity itself. And so it's a very important criterion. And so you saw, what is it really? What is connectivity? This is a simple definition. It describes the linkages, ecological linkages between locations, between habitats, both of organisms, so animals that are moving from one location to another, but also resources that they require. So it could be that the food for one organism is in two different places, and I'll show you an example. Here, this is a slide that you saw yesterday or the day before that illustrates different connections with those arrows that you see here. So here's an example of resources. We know that the deep sea does not have its own primary production except at hydrothermal vents. So the food always rains from the top. And so here's phytodetritus, dead stuff. that will sink to the seafloor and will provide food for the organisms that live there. So here we have a connection, not of animals, but of resources. And so obviously this is important to maintain as well. Now, what you see here at the bottom also, and people did not mention that very much yesterday, is here's a schematic of hydrothermal vents with two berms. These are deep water corals. And what you see are these little dots here. And so what these little dots is are propagules, they're larvae that are a very important life history stage for these particular organisms. And so for most of these species that live in the habitats that deep sea mining will target, these are organisms that have what are called complex life cycles. So what happens is the adults, things like tuberums or mussels, are attached to the seafloor and they don't move very far. And so they can't really connect when you think about it. But what these adults do is they release propagules in the water, or eggs and sperm, and fertilization happens in the water. And so these propagules, these larvae, are essentially zooplankton that just drifts passively with the currents. And so this is the only stage in their life of those organisms that is actually moving. And it's the only stage that can actually provide those connections for a particular species that is attached as an adult. And so the reason we care so much about connectivity in the deep sea is because many of the species that we're working with are either completely attached, like this that you see here, or they move very short distances compared to, you know, how far apart the habitats may be. And so that's why we care. Now, let's get back to specifically deep sea mining and you know, how does all this relate to deep sea mining? Well, the International Seabed Authority has produced some guidance to facilitate what they call the development of regional environmental management plans. Those are plans that are specific to particular regions, North Atlantic, Northwest Pacific, and they are the plan, the spatial plan, if you wish, of how those activities in those particular areas are going to be managed. And one of the tools in that toolbox, of course, are area-based management tools, which are essentially what we have been calling marine protected areas this far in the talk. And so marine protected areas, which are called something else, and I'll get to that in a minute, in the ISA, are actually an integral component, at least, of the regional environmental management plan, or are supposed to be. So has this happened? Has this sort of design of marine protected areas in relation to deep sea mining actually happened? Well, there was a group of scientists that got together and actually tried to come up with designs of networks of marine protected areas based solely on the scientific criteria that I presented to you earlier. The characteristics that I'm talking about: connectivity, replication, viable sites, etc. And so they targeted, this is the CCZ, so they use this as their study area. And what you see here in the three panels on the right are potential designs of networks of marine protected areas. So in this instance, it's called marine protected areas. Each one of those numbered boxes corresponds to one of those, a marine protected area. So this was a proposal of different arrangements of marine protected areas based strictly on the science. But what I would like you to focus here on this number 8 and 7, because then what I'm going to show you is how was this arrangement picked up and finally approved of and implemented by the International Seabed Authority. And so what you see here is those boxes that are now called APIs, and APIs are areas of particular environmental interest, aka NPAs, but this is in ISA lingo, in the Clarion-Clipperton zone. And you can see that some of them are in the areas that were proposed to be, but then some, but some are not. And so what you see here in the middle is that's why I pointed those ones earlier on, that here in the middle, we don't have those squares that we had earlier, but what we do have is a lot of colors, and what these are existing contracts. And so what we have here is we have this problem of the science recommending one particularly the most effective design. But in the flip side is, you know, you have the economics where some of those places are really taken up. And so are they going to be given up for protection? that means that those contracts can no longer be mined. So that's a problem. Now, I will bring you to the other side, to the Atlantic, in a process that several of us on these calls were involved in. And this was a purely scientific exercise to do a similar kind of process, but in the North Atlantic and in mid-Atlantic ridge, in the region that is actually identified here with this red boundary. And so here what we have is, again, as you can see, several contracts arranged, pretty much covering most of the northern part of the mid-Atlantic ridge. So what this exercise did is a group of scientists got together and used those criteria, those scientific criteria that I discussed with you earlier, to come up with potential designs for networks of APIs. And so 3 different approaches were used, or different ideas. And again, this was simply building scenarios so that we can go through this exercise and see how do we actually do this exercise systematically. And so in this example here, you can see the boxes B, C, and D vary. Each one of those boxes is the API. And so in B, you have lots of smaller APIs that are closer together, whereas in D is the other extreme, we have fewer that are bigger, but they're farther apart. And so these are different scenarios that don't really mean anything other than trying different dispersal distances versus sizes and looking at how that will affect connectivity versus viable populations, so playing with those different exercises. And then once these were set up, then specific criteria were used to score how well they performed for the criteria. And so what you see here on the top are all those criteria that we saw for networks, important areas, representativity, connectivity, replication. And I don't really want you to worry about what the actual numbers are here. What I want you to look at is there is a way to do this systematically. And so what this group did is then went through each one of those scenarios and scored on some arbitrary metric here. How well did the scenario do in terms of capturing important areas? How well did it do in terms of capturing connectivity? So while the answer is not necessarily the right or the wrong answer, this process illustrates how it can be done in a systematic way, taking into consideration all the scientific criteria. So getting back to this, because at the end of the day, this is what we need to get to that stage. And so, as we said, there's planning, then based on your goals and objectives, you need to collect the data. And then based on those data, you characterize your ecosystem. Based on your ecosystem characterization, you come up with how you're going to manage activities in that ecosystem. And we heard yesterday and the day before a lot about gaps that we have in data, and also given the gaps in data, in being able to characterize the ecosystem in a way that then we can have management applications that are meaningful and will be successful in meeting those goals and objectives. And so what the International Seabed Authority is trying to do over the next 6 to 8 months, many of us are involved in, is they're running a series of workshops where they're going to do all of those steps in each one of those workshops for different parts of the world's oceans. So there's one that is starting next week that is looking at all that data that has been collated and then trying to do ecosystem characterization for the Northwest Pacific. Then there's another one later in November for the Mid-Atlantic Ridge. And then there's another one later again for the Indian Ridge. And so this is where we're at, but you can see that there's a lot of work that needs to be done to go from those goals all the way to actually come up with a reasonable management plan. So I'll stop there and thank you for listening.